So I might know a little bit about exponent numbers, and I might know about the base and the power that goes up top, or I might know how to write them in expanded form, but how do I find out what they're really equal to? No exponent number, no multiplication. What are they actually equal to? What number is an exponent number equal to? That is what this video is going to teach you how to find. Let's start with a really simple example. Our base is going to be 2. 2 is a good base because it's really easy to multiply. And let's say our power is 4. Power is going to be 4. Alright, so that means that, well, the base is the number that I'm talking about, and the power is that number that tells you how many times you're going to multiply it by itself. So 2, that's going to be 2, the number I'm talking about, times 2 times 2 times 2, 1, 2, 3, 4, 1, 2, 3, 4 times. And that's great. I can take my exponent number and I can write it in expanded form as a long multiplication problem. But now how do I find what this is all equal to? Well, that's super easy. All I've got to do is say 2 times 2 times 2 times 2 equals, but we might not really be able to do that up in our heads. So here's one method that works really well. All I say is, well, I know what 2 times 2 is. That's going to be 4. And I know what 4 times 2 is, right? I'm dropping this 2 down, and I'm going to actually drop this 2 down. So it's going to be times 2 times 2. So I just got rid of these two 2's. So times 2 times 2, well, that's 4 times 2 times 2. Well, 4 times 2, that's going to be 8. And now I only got one more little times 2 to drop down. 8 times 2, well, that's 16. Drop it down, you get 1, 6. 16. So you know that 2 times 2 times 2 times 2 is actually equal to 16. How do we solve this? Well, we just grouped them. We said 2 times 2 is 4. We dropped these 2 down. We said 4 times 2 is 8. We dropped this 2 down. We said 8 times 2 is 16, and that is how we got our answer. Let's look at a problem that maybe you could do 2 times 2 times 2 times 2 up in your head. Let's look at a problem that you're definitely going to want to use this grouping method for. Six to the third. 6 to the third power. Well, we know that 6 is the number we're talking about, so we got to say equals 6. How many times am I going to multiply it by itself? 3. How many times am I going to multiply it by itself? 3, because the power is 3. 6 times 6 times 6. 1, 2, 3, and 6 is our base. Good. So 6 times 6, again, I'm just grouping. I'm just dropping this down. 6 times 6, that's going to be 36. And I've got one more 6 left, so I can just drop it down. Now 36 times 6, I'm going to have to do this on my scratch paper, which is going to keep over here. 36 times 6. Well, we know that 6 times 6 is 36. And we know that 6 times 3, well, 6 times 3 is going to be 6, plus 6 is 12, plus 6 is 18. So we also have to add this 3. So 6 plus 6 plus 6, that's 18, plus this 3 that we had up top, that's going to be 21. So 36 times 6, that's going to be 216. 216. So 6 times 6 times 6 is actually 216. It equals 216. How do we get to that answer? Well, we started by saying, well, 6 times 6, that's 36. I just dropped this 6 down. 36 times 6, that's 216. There is no way, unless you're a math genius, that you can do 6 times 6 times 6 really fast in your head. So what you need to be able to do is you need to be able to group these numbers. You need to go down. 6 times 6 is 36. And then you drop the 6 down. 36 times 6, well, that's going to be 216, giving you your final answer. Let's look at a slightly different example that has the same principles, but it's going to stretch our understanding of exponents. What if we get something that looks like this? What if we get something that looks like 0.5 raised to the third? Now these parentheses just mean that I'm talking about 0.5 and not raising 0.5. So I'm talking about 0.5 raised to the third. Well, how can we use our understanding of exponents and how they get into expanded form to solve this problem? Well, our power should be telling us that I'm going to multiply this thing by itself 3 times. 3 times. And we know what our base is. It's just not a whole number. It's just 0.5. So you got to be thinking, well, I got to multiply 0.5 times itself. How many times? Well, it tells you. 3. Let's try it. 0.5 times 0.5 times 0.5. You got it. You don't really need to know how to do decimal multiplication to do this. You just need to know that, well, 0.5 to the third power, that means it's going to be the base, 0.5, times itself, 1, 2, 3 times. Now, you got to start doing some decimal multiplication. Let's do it. We can say that 0.5 times 0.5, whoa, I don't even know that one, so I got to go to my scratch paper. 0.5 times 0.5, doing it vertical style. 5 times 5, we know that's 25, so our 2 goes up here, and our 5 goes down here. 25. 5 times 0, well, 5 times 0 is going to be 0. Plus 2, because we had it up here, is going to give us 25 right here, 25. Now, we need to move over. We have a placeholder 0. 0 times 5 is 0, and 0 times 0 is 0. We add them up, and we get 5, 2, 0, and we know that we have one number behind the decimal place, and 2 numbers behind a decimal place. That means I got to get them back. 1 number, 2 numbers. Boom. We move our decimal 2 places over because we had 2 numbers behind a decimal place. So that's going to give us 0.25. Let's write it, because 0.5 times 0.5 is going to be 0.25. Now, what do we do with our grouping strategy? We drop this down, 0.5, and we multiply, because we drop the multiplication as well. So 0.25 times 0.5, I definitely can't do that in my head, so I need to go to my scratch paper. Let's erase what we had, and throw up the new problem. 0.25 times 0.5. When you're doing decimal multiplication, you just throw them all, you just write the decimals however they come. So you're like 0.25 and 0.5. So notice how these decimals are not lined up. You don't need to line them up. Decimal multiplication, you do not need to line the decimals up. It does not matter. Let's do it. 5 times 5, that's 25. 5 times 2 is 10, plus that 2 is 12, so I'm going to get 1, 2. 5 times 0 is 0, plus that 1 is 1. Now we got to do our placeholder 0. Make a better X. 0 times 5 is 0. 0 times 2 is 0. And 0 times 0 is 0. Let's add them up. 5 plus 0, 5. 2 plus 0, 2. 1 plus 0, 1. 0, that's just going to be a 0. I'm just going to leave it out. And we get 125. But wait! What haven't we done? We got to look up at the top and see how many numbers we have behind the decimal point. How many do I have? Well, I have 1 here because it's behind the decimal point. I've got 1 here because it's behind the decimal point. And I've got another 1 here because it's behind the decimal point. I've got 1, 2, 3 numbers behind a decimal point. So I got to go 1, 2, 3, boop, and I get 0.125 or 0.125. That's going to give me 0.125 for my answer. And again, the grouping strategy is the same. We just say 0.5 times 0.5, that's 0.25. And then we say, well, I got this and I got to drop it down. 0.5 times 0.25, that's 0.125, as we saw in our scratch work. Good luck with your quiz.